Friends, in this session we study about the types of function. In types of function we will study in this session about the Signum function, exponential function and logarithmic function. So first of all I would like to explain the Signum function. Now look at this. There is Signum function. We have the function f defined by f of x is equal to mod of x over x, where x is not equal to 0. If x is equal to 0, it is 0. So I would like to explain you here. If I have f of x, if we take x is equal to 1, put x is equal to 1. So what we get here, f of 1, get here mod of 1 over 1, which is 1. If we put x is equal to minus 1, if we put x is equal to minus 1, we get f minus 1 is equal to minus 1, mod of minus 1 over minus 1. So we know that the mod of any number is always positive, 1 over minus 1, which is minus 1. Now if we put x is equal to 2, then we get f of 2 is equal to mod of 2 over 2, which is again 1. Now finally if we put x is equal to minus 2, then we see what happens now. F of minus 2 is equal to mod of minus 2 over minus 2. Mod of minus 2 is 2, in denominator there is minus 2, so we get minus 1. So look at here, whatever we are putting the value of x, we get either 1 or minus 1, always. And the x is equal to 0 is always given. It is given already that x is equal to 0, where f of 0 is 0. So we get here 1 point. And if we put any value of x, we get always minus. If we put the positive value of x, we get 1. So here, if you put any value here, so we get 1. If we put any negative value instead of x, we get minus 1. So in this way we get the graph of Signum function. Either we get 1 as a range, minus 1 or 0. So the domain of this function, because it is x, so we can put any value instead of x. So the domain is R and range is only 3 values are there for range, minus 1, 0 and 1. These 3 values are there for range, minus 1, 0 and 1. So this is all about the Signum function. Now we study about the exponential function. Now I would like to explain about the exponential function. This is very important, one of the most important functions here exponential function if a is positive real number other than unity, not equal to 1, then a function that associates each x belongs to R, the domain is R here, to a power x is called the exponential function. In other words, we could say that f R to R defined by f of x is equal to a power x, where a is greater than 0 and a is not equal to 1. Okay, so in this condition we see that a is not equal to 1, so a may be smaller than 1 between 0, because a is greater than 0, so between 0 and 1. And another is a is greater than 1. So we have two conditions. The case 1 we see here, case 1, first case we see here. First case we see that a is not equal to 1, a is greater than 0. So we are taking that a is greater than 1. The case 1 we are taking as a is greater than 1. So here I would like to explain the graph of this. For this I explain that f of x we have is equal to a power x. Here we get that it is smaller than 1 if x is smaller than 0. If x is smaller than 0, then it would be smaller than 1. It is negative. So a power a is any number greater than 1 if we take 2 or 3 and 5. I will explain later. First I would like to write this all is equal to 1 if x is equal to 0 and it is greater than 1 if x is greater than 0. So now I would like to explain this. First we see a is greater than, we observe that if we observe this all with this example, I would like to show that if x is greater than 0, if x is greater than 0, we are taking first this one, x is greater than 0 and a is greater than 1. You know that here we have taken the condition that a is greater than 1. If x is greater than 0, then 2 power x is smaller than 3 power x is smaller than 4 power x is smaller than so on, if x is greater than 0. So now I would like to explain how it comes. X is greater than 0, we are taking 2 power 2, x is equal to 2 we are taking here. X is equal to 2. So what we get here? What we get here? 2 power 2 which is equal to 4. Then 3 power 2 which is equal to 9 and 4 power 2 which is equal to 16. So here you see the 4 is smaller than 9, is smaller than 16. So here you see 2 power 2 is 4, 3 power 2 is 9 and 4 power 2 is 16. So this is the way we are getting here. Now if x is equal to 0, we see what happens now. So 2 power 0, because if x is equal to 0, then 2 power x is equal to 3 power x is equal to 4 power x is equal to and so on, and all equal to 1. I explain here 2 power 0 which is 1, 3 power 0 which is also 1 and 4 power 0 which is also 1. So any number if we get the power 0 it is equal to 1. So this is. Now I would like to explain that if x is smaller than 0, we are taking this one now, x is smaller than 0. If x is smaller than 0, if x is smaller than 0, then what will happen? 2 power x, here the 2 power x is greater than 3 power x is greater than 4 power x, and so on here. So in this way we get here. Now I explain you this. If we are taking x is equal to minus 2, then we see what happens now. 2 power minus 2 is equal to 1 over 2 power 2, which is 1 by 4. Okay. Now 3 power minus 2, which is 1 over 3 square, which is 1 over 9, and 4 power minus 2, which is 1 over 4 square, which is 1 over 16. So here you see the numbers what we are getting here, 1 over 4, then 1 over 9, and 1 over 16. So in the numerator, all the numbers are same. 1 is there in numerator, and denominator, the smallest number in the denominator, it would be the greatest one. The value of this number would be the greatest one. It is 0.25. If 1 over 9 is there, 0.1, it is 1, so on. And 1 over 16 if we have, it is 0.006. So it is 0. You see here 1 over 4, 0.25, 1 over 9, 0.11, and 1 over 16, 0.06. So this number is greatest one, and this is the second greater, and this is the smallest number. So we get here that it is greater, and it is. So here you see 2 power x is greater than 3 power x is greater than 4 power x, and so on. So in this way we could easily find out these all. So this is the way we have seen here. Now we make the graph for these. First I would like to make the general graph for this. It is 1 we have, and I draw a graph here. This graph we get here, because in this way we get this graph. So it is y is equal to a power x, where a is greater than 1. We get this sort of graph, because on the right side of x is greater than 0, we are getting the greatest value of a of x, and x is smaller than 0, then we are getting the smaller value here. Okay, so we get in this way. Friends, here I would like to explain you if x is smaller than 0, x is equal to 0, and x is greater than 0, how the graph works here, how the function graph should be there on graph paper. Here is a point we have 0, 1, it is x is equal to 0 and y is equal to 1. This is our x-axis and this is our y-axis, this one is our origin. So I draw one graph here for y is equal to 4 power x. We are making first graph, and then y is equal to 3 power x and y is equal to 2 power x. So first I draw the graph of y is equal to 4 power x. So we see what happens now. This is our y is equal to 4 power x. Here also I am writing y is equal to 4 power x. Just a moment. This is a y equal to 4 power x. Now another graph I am making, 3 power, y is equal to 3 power x. This is our y is equal to 3 power x. I am also writing y is equal to 3 power x. And another graph I am putting here. This one is y is equal to 2 power x. Here I am putting y is equal to 2 power x. So here you are seeing that if x is greater than 0, if x is greater than 0, we see that 2 power x is smaller than 3 power x is smaller than 4 power x. So you see here the 2 power x is smaller than 3 power x is smaller than 4 power x. Here you see if x is equal to 0, 2 power x, 3 power x, 4 power x, all is equal to 1. So x is equal to 0, we get the whole are same. It is equal to 1, if y is equal to 1. Now if x is smaller than 0, if x is smaller than 0, if it is the negative side of this, you see the 2 power x is smaller than 2 power, sorry, here you see in the left side here, 2 power x is greater than 3 power x is greater than 4 power x. So in this way we get this graph. So this is a way to form the graph of an exponential function if a is greater than 1. Now you see the case 2. Here we have the case 2 that 0 is smaller than a is smaller than 1, because we have taken a is greater than 1, we have taken here. Now the a is smaller than 1 and greater than 0. So 0 is smaller than a is smaller than 1. The second case we are taking here. So here if we see this, the domain would be R for all x belongs to R, as is mentioned here. And if I draw this graph, if I would like to explain this, now we put here, I explain you f of x, y is equal to f of x, which is equal to a power x. We have, now we put here some conditions. It is greater than 1 if we have x is smaller than 0. It is equal to 1 if x is equal to 0, and it is smaller than 1 for x is greater than 0. So this is the way we see here. It is a just reverse of that what we have studied in case 1. The graph would be totally changed. So first I would like to explain here by this graph. A is smaller than 1, then if a is 1 by 2, if I put a is 1 by 2, if a is equal to 1 over 2, you see what happens. So for this we see x is smaller than 0, the condition, and x is smaller than 0, or we could write that x is equal to minus 2. We are taking here smaller than 0, minus 2. So what happens? A is 1 by 2, f of minus 2, which is a, we are putting 1 by 2, and the power is minus 2. So we get 2 power 2, which is 4 now. Another we are taking, f is this is 2 power 2 is 4, we are getting at minus 2. If x is equal to 0, if x is equal to 0, so what we get? F of 0 of 1 by 2 to the power 0, which is 1. Now x is greater than 0, if x is equal to 2, we get here f of 2, which is 1 over 2 power 2, which is 1 by 4. So if we get the greater, if we go to right side on x-axis, we get the smaller than 1 number always, because we get, if we get 2, so it is 1 by 4, if we get 3, 1 by 9. So as the number increases on x-axis, the range would be decreased, the y would be decreased. And if the number decrease in here on the left side, axis decreases, x is smaller than 0, then the y will increase. You see here the x is minus 2, then y is 4. So if we put x is minus 3, then y is 9, so the number will increase. If we go to the left side on the x-axis, the number will increase. So here we put the number like this, and the graph would be like this. I would like to explain here. Graph would be like this. So this would be the graph of this sort of functions if a is between 0 and 1. So this would be a graph. We could write that y is equal to a power x if 0 is smaller than a is smaller than 1, then the graph would be this. And the previous we have seen that the graph in this way, here the graph in this way. So I would like to explain some other thing also, as we have done there. The same thing would be there, the same graph I would like to explain now. Now I would like to explain now in detail. We have 0 is smaller than a is smaller than 1. It means the a is between 0 and 1. We have, in this case, we got these all conditions. If a of x is greater than 1, if x is smaller than 0, and we have made this graph also according to this. Now I just want to explain in this order. We are taking the values a is equal to 1 by 4. Then second time we will take the value 1 by 3. And the third time we will take 1 by 2. It is in ascending order. 1 by 4 is the smallest one, then it is the smaller, and it is the greatest one. So these three values we will see, the graph of these three values, as we have seen in our previous case. And for x is smaller than 0. Here you see, for x is smaller than 0, it means we are taking here x is equal to minus 2. We are taking x is equal to minus 2 and a is equal to these all values. We will see what happens now. If we are taking a is equal to 1 by 4, then a power x is equal to 1 by 4 power minus 2, because x is minus 2 and a is 1 by 4. So we are getting here 4 power 2, which is equal to 16 we have now. So it is 16, which is y we have, and x we have minus 2, and a we have 1 by 4. So if we are taking a is equal to 1 by 3, then a power x is equal to 1 by 3. X we are taking minus 2 here again. So it is 3 square, which is equal to 9, which is y we have. And finally we are getting a is equal to 1 by 2. So we get a power x is equal to 1 over 2 power minus 2, which is equal to 2 power 2. It is 4, which is 1. So look at here, 1 by 4 power x. 1 by 4 power x, which is 16, is greater than 1 by 3 power x, which is greater than 1 by 2 power x. As a increases, a we are increasing, a is smaller here, 1 by 4, which is greater. If the a increases, the y decreases. You see here the y decreasing order, the 16, 9 and 4. So it is decreasing. If the x increasing, y is decreasing. Now friends, we see that if x is equal to 0, we see what happens here now. X is equal to 0, we see. For a is equal to 1 by 4, we see that 1 by 4 power x, which is 0, is 1. 1 by 3 power 0 is also 1. And 1 by 2 power 0 is also 1. We get always 1 here. Now, we see finally the last one. If x is greater than 0, x is greater than 0, so we are putting here the value x is equal to 2. So we see what happens now. For a is equal to 1 by 4, we see a power x is equal to 1 over 4, a is 1 over 4 we are taking here, and x is 2 here, so we get 1 over 16, which is y. A is equal to 1 over 3, we get here a power x is equal to 1 over 3 whole square, which is 1 over 9, which is y. And finally we get a is equal to 1 over 2, which is a power x is 1 over 2 whole square is equal to 1 over 4, which is y. So here you see, as we increase a, the value of this, here is the maximum value, so the value of these would be minimum. So if a increases, here you see, if x is smaller than 0 or the negative, then if a increases, y decreases, a power x decreases. So for x is smaller than 0, if a increases, a power x or y decreases. Now here you see, if x is equal to 0, for x is equal to 0, you see the value of all a power x is 1. So we get here a power x is always 1. For x is greater than 0, if x is greater than 0, x is positive, then if a increases, y or a power x is also increases. a power x also increases. So now I show you this on graph how it looks if we draw the graph of this all function. It is y is equal to 1 by 4 to the power x. There also I write the same thing, y is equal to 1 to the power 4 x. Now another graph we are drawing here. This y is equal to 1 over 3 power x. This y is equal to 1 over 3 power x. Last one we draw here. So it is y is equal to 1 over 2 power x. Here also y is equal to 1 over 2 power x. So here you see if a increases, x is smaller than 0, x is smaller than 0. If a increases 1 by 4, 1 by 3, 1 by 2, it is increasing, then a of x is decreasing. Now a of x is decreasing, the y coordinate is decreasing here. If 1 by 4, it is the highest y coordinate, 1 by 3 is middle between them, and 1 by 2 it is the lowest one. Here you see if x is equal to 0, you see here we get ax is always 1, a of x is, a power x is always 1, y is 1 always here. And here if we see that x is greater than 0, if a increases, a power x also increases, it means y also increases, a increases. A is 1 by 4 with the small one, the y is this one is small length of pi here. 1 by 3 it is the greater length here, it is the greatest length for 1 by 2 here. So in this way we could understand this graph for exponential function. So thank you for this.